Welcome to Is This Funny to a Teenager?
Just hands.
This is Abby.
Hi.
The way this works is I show Abby a cartoon. If she thinks it's funny, she's going to show them the emojis.
It says this one.
She'll pick them emojis. And if she picks one of those two, you get to see the cartoon after this segment. If she thinks it's bad, you'll see one of them. And you'll never get to see what the cartoon was. Okay, are you ready, Abby?
Yeah.
I love this one a lot. I really hope you laugh at this one, because I really want it to go.
That's so good. I can definitely relate to that one.
Yay! You're not even a physicist. How do you relate? You just get it.
Yeah.
Thanks, Abs. All right, you're going to see it right now. Hello again, grade 5, 6. It's really nice to see you tune back in again this week. I really enjoy hearing from you and seeing the photographs of your experiments, and that some of you have set up your sourdough starters and things already, which is great. Today in this video I'm going to show you how to bake bread with it. I've been eating yummy bread for the last couple of weeks now, and hopefully that will be you soon too. But today I want to start introducing to you what we're doing for the rest of this term, which is to do with physical change and chemical change in science. I'm going to start by looking at physical change. So when physical changes happen in science, we're talking about something that maybe changes its shape, or maybe changes its size, or maybe changes its state from a solid to a liquid, but the actual chemicals that make it up and the molecules that are inside it aren't changing. They might just be shifting a little bit or moving into a different way. So these are pretty easy to tell generally. Here's some examples coming up now. One example could be an ice block melting. It goes from a solid to a liquid, but it's still H2O with 2 hydrogens and 1 oxygen atom attached together in those molecules. It's just that they're kind of spread out a bit more in a liquid than they are in a solid. So melting is one of those. What about if I gave you a piece of paper and we ripped it into pieces? Now, it's still paper, it's just in a million bits now, but it hasn't changed chemically, it's just changed its shape and form. So that's a physical change. Right, what if we got a bunch of marbles and we mixed them all up together in a pile? So we used to have red ones and we used to have green ones and we mixed them together, now we have red and green marbles. That's a physical change. We have a mixture now, but the marbles are still whole marbles as they were beforehand. They haven't changed chemically. What about if I got a glass and I smashed it? Then the glass is all broken into pieces, but it's still glass. It hasn't changed chemically. So I think you're probably starting to get the idea. It's not too hard to understand physical changes. Now, chemical change, on the other hand, is probably what most people find interesting. Chemical changes are when something changes and the actual chemistry, the actual molecules that make it up, change somehow. Now, they might be broken apart, they might mix together with something else. And often in a chemical change, there is a new thing produced. So, for example, if you are baking a cake and you put all these different ingredients together and you cook them, they actually mix together, and with the heat, they change into something completely different and you have a new product at the end. Or what about some food decomposing? So a banana sitting in your fruit bowl. I don't know if you've ever watched that. And it goes from being this beautiful, yummy, yellow thing to this disgusting, black, moldy kind of stuff. And that is also a chemical change. There's creatures in there, maybe bacteria, microbes that are breaking that down, and the actual chemicals inside that banana are changing and breaking down. You might have seen things rusting. We're going to talk about that in next week's lesson. And with rust, you've got an object that just looks nice and then something happens to it, a reaction of some kind that you don't know about yet, and then it turns into something else. You get something else on the surface of it that wasn't there before. It's a new thing. It's a chemical change. All right, you're probably all familiar with fire. We all love fire. In fact, in a few weeks, we're going to be doing a little bit of fire in our lessons. But you'll be all familiar with candles burning, maybe even campfires. I actually have a fire in my lounge room, an open fire. And so what you do is you put all the sticks in there and you set them on fire, and then the sticks are just gone. But you get heat and you get this ash stuff in the bottom. So something's clearly changing in there. It's a chemical change because the thing you end up with is really different to the thing that you started with. So as I suppose our first example of a chemical reaction is what we've been doing in the last couple of weeks with yeast. And I showed you the molecules and I showed you how you start off with glucose molecule and it mixes with oxygen in a process called respiration, and then that changes to become water and carbon dioxide. So we have two things that change to become two different things. Definitely a chemical change. So in the bread you make this week, you are exploring a chemical change, not only from that yeast, but then baking things together to make bread.
So to start this recipe off, you need 150 grams of your beautiful little yeasty starter. I know this is sad because they're going to die. Anyway, you put it into a bowl and you whisk it up with 1 cup of water. Now it's better if the cup of water is actually a little bit warm. So I've added some boiling water in there to my normal water to make it a little bit warm. So that's 250 mils of flour. And then you whisk it up and also add in 25 grams of oil, which is around about a tablespoon if you don't have scales. And once you've whisked that up, you add 500 grams of flour. Now I use this special bread flour. I haven't tried it with other types, but you can give it a go. And 10 grams of salt as well. Then you just give that a mix up. It actually looks a little bit like a shaggy kind of dough. It doesn't look smooth and beautiful. I usually mix it with the spoon first and then I get in there with my hands and give it a bit of a stir. You don't need to really knead it or anything, but you can see here I'm shaping it into a vague ball kind of shape. And then you put it in the bowl and leave it there for 12 hours to rise. Because it's really cold at the moment, you could even do it for longer. So maybe if you put it in, say in the afternoon, the day before, leave it overnight, and then in the next morning, you can cook it up. Now, just so I don't forget, I'm giving my starter some more food so that it's ready again for the next day. Because I took so much out of it, you can even double the food sometimes if you want more, and if you're going to be making bread a lot.
Okay, hello, it's baking day. Last night I took out some of my sourdough starter and I mixed it into a dough, which I showed you in that video. And this is it today. When I woke up this morning, it wasn't very big. So I just warmed up my oven a tiny bit and let it go in there this morning, and now it's like, it's quite large. Look at that compared to last night. So I'm going to show you how to do the next step, getting the bread ready. And by lunchtime today, if you start this early, by lunchtime you should have a beautiful loaf of bread for your family to share. So I use baking paper for this. You can do this other ways. You don't have to do exactly the same as me. But I find this the best way for me. So baking paper. And I just dust that with a tiny little bit of flour. Like this. And then you scrape the dough out of the bowl onto the baking paper. It does get a bit sticky, and I don't want to squash it too much and squash all that great carbon dioxide out that the yeast has made. All right, there we go. Now, sometimes this smells a bit like alcohol. Sometimes it smells a bit like vinegar. So today mine smells like vinegar. And apparently in the colder months, you get that more vinegary smell. Now, I don't know if you can see what I'm doing here, but I'm just folding over from underneath, folding the sides over. And I just do that 4 times, all into the center like that. And pick it up, oops, a bit so it makes a ball. And kind of tuck those folds. So there's the folds on your side. And on my side, I've got a nice dome on the top. So fold it into a ball. Don't spend too long on it. You don't have to knead it or anything. It should be nice and soft now. It's actually quite squidgy. And then you have to leave it to rest for another 1 to 2 hours, depending on the temperature. I usually, in this cold weather, probably 2 hours, but no more than that. So I'm going to leave this and set my timer. So in 1 hour, I'm going to turn on the oven. So I'll set this for an hour. All right, so this will rest for 1 hour. Then I'll put the oven on for half an hour to get it hot. That's an hour and a half. And then that gives me kind of a half hour to play with to get this into the oven after that. All of these instructions are written in a recipe that I've put together for you. So if you want to read through that, that might help. And if you have any questions, let me know. And I'll be back in an hour and a half to show you what to do next. Right. Okay, so I let this rest for an hour. I turned the oven on. It's been going for half an hour. And now I'm just going to get out the crock pot and cook some bread. Sprinkle a little bit of flour on top of the bread, and then with a sharp knife just give it a little slice from the top. This will allow the bread to kind of rise out of the center. And turn your oven down to 200 degrees. Okay, give it 20 minutes and then we'll take the lid off. Okay, I've just taken the lid off. Now give it 20 more minutes. The timer's gone off. It's time to get it out and have a look. Oh yeah. Check that out. So make sure you let it cool right down before you try to eat it, or it might be a little bit kind of gummy inside. And it does taste a little bit sour because it's sourdough. It's meant to taste that way. I'm sure that your family is going to be super grateful for all your efforts, and I'm really pleased to hear that some of you have given it a go as well. All right, see you next time. When I was a young girl, my parents joined us up to the zoo, and we used to go there all the time as a family. And one of my very favourite enclosures to go and see was the great flight aviary, which had all these birds in it. And if you've been to the zoo, you'll know it. There's this huge aviary, and through the middle of it is a boardwalk that is actually risen up above the ground, and you look down onto the birds in this incredible cage. Now, in particular, I remember always wanting to see this one bird, and it was called the Satin Bowerbird. And this bird, I've drawn another beautiful picture for you. This bird actually collects things. And I used to look forward to seeing it because every time we went there, this bird would have as many blue things as it could find around its bower. Now, bowerbirds are notorious for collecting things. They collect anything they can find, but it has to be the colour they like. And each species has a different colour that they like. So the satin bowerbird, which is a dark blue, almost black kind of colour, collects blue things. But in real life, I've seen a satin bowerbird nest. I'll show you right now. So in that photograph, you can see blue straws, blue bottle tops. Then we went to Northern Territory, and up there, one day I heard this bird going nuts in the tree, and I looked over and saw there was another type of bowerbird in the tree, and it was called a great bowerbird. And great bowerbirds, they don't collect blue things, they like white things and green things and grey things, and so the bower that they made was all green and grey and white. So have a look at this photo. My mum and dad saw a bird in Central Australia called the Western bowerbird, and that one was collecting white things, and it had little snail shells and bits of bones and things like that in there. Now, I love all the Australian ones a lot, but when I was researching this, I actually found a video that I'd seen years ago by David Attenborough about, I think, the best bowerbird on the planet. It's called the Vogelkop, which in German means bird head. It's a bird head. And this bird creates a bower unlike anything you've ever seen. I'm going to attach a video in Google Classroom that I'd love for you to watch after this one and just see what this bird collects. They collect beetle wings. They collect red, orange flowers. They collect fungi and put them in beautiful little piles. One of them even collects deer poo with little fungi growing out the top of it. And not only do they collect all these gorgeous things, but they put them all in little piles around their beautiful bower, which is shaped a bit more like a tent, I suppose, and they attract females to that. They are absolutely gorgeous.
Last week on Science in Legoland. "430 Whitehorse students radioed in to help Danielle and Sunny solve the mystery of why sand can be different colours. These were some of the responses. The next day, at school, Danielle and Sunny gave the sand to their science teacher, who showed them what it looked like under the microscope.
Sand is different colours because it can be made of so many different things. Let's have a look at a few.
The sandy sand looked like this. The brownie sand looked like this. The white sand looked like this. The purplish sand looked like this. And the black sand looked like this.
Some sands are made from tiny pieces of rock, others are from different coloured minerals, and some are made from tiny shells and animal skeletons.
And with that, the mystery was solved. Did you guess why sand is different colours?